Hey guys, so just for a short amount of time, Coach Moss is going to go over graphing rational functions step by step. I'm not going to go through all of these rules. I definitely advise you to read them, but I will go through the steps myself. Here also on the side are some notes that I've written out to kind of help me and also help you. Please feel free to write these down, like pause the video, write these down. This is all basically the rules for asymptotes and how we have to make sure that we pay attention to which one is which and while we're graphing. So the slant is always going to be when the exponent on top is one more than the bottom. The vertical asymptote, you're only always looking at the denominator because that's basically when the denominator is 0. And then horizontal asymptotes comes down to exponents as well, just like slant. When they are equal, then you put the coefficient of the numerator over the coefficient of the denominator. When the numerator on the exponent of the numerator is greater than the denominator, there is no horizontal asymptote. And then when the exponent of the numerator is less than the denominator, then it's at y equals 0. All right, wholes are always canceled out x values from the top and the bottom. All right, so I'm going to leave number 1. Obviously, it's in the notes done already. This is a very simple one. I kind of wanted to work on some that are a little bit more difficult. This one has a slant. I'm going to help set this one up, but I'd like to see what you can do on your own there. And then this one I'll go through as well. So I'm going to do 2 of them. I'm going to set up a third one, and then I'm going to leave this first one. I also have already set up to where it has all these things ready for me to fill out. And I've also went ahead and made an XY column. That's going to be very beneficial when it comes to actually attempting to kind of shade the graph as it goes. All right, so I am going to start with number 2 here. We have x squared plus x minus 2 over x minus 3. I always recommend doing these first. All right, so first thing I'm going to do is change how the top looks, factor it out. So for us, that's going to be x plus 2, x minus 1 over x minus 3. Now, we don't need this to look at the horizontal asymptote or the slant because we have to look at the exponent. So we have x squared over x. So my numerator is greater than my denominator, which means that I will have no horizontal asymptote. However, when it comes to the slant, if the exponent on top is 1 more than the bottom, we have 2 over 1, then there is a slant asymptote. And to find that, we have to do long division. So we will do that in just a minute. But I'm going to actually keep looking real quick and just make sure we have everything else. So vertical is talking about the bottom. So our denominator is x minus 3. So if 3 were x, then our denominator would be 0. So there is a vertical asymptote at x equals 3. All right, there is no hole because we haven't been able to cancel anything out. So let's go ahead and do our division and find where our slant is. So we have x squared plus x minus 2, and we are dividing that by x minus 3. We're dividing that by the denominator. All right. Once we do that, we get x squared minus 3x, subtract. So we get 4x. Ooh, I'm going to try to get my camera to focus in a little bit better. I'm sorry about that. Minus 2. And then we end up with 4. Now, a lot of times when you do this, there will be a remainder. Sorry about that, but we don't need it. The remainder won't matter in this case. So even though there is one, all we're worried about is this, because we're putting it in y equals mx plus b form. So there is a slant at y equals x plus 4. Okay, so let's start by graphing our asymptotes. We have a vertical asymptote. That means up and down, x equals 3. So where x equals 3, I'm going to go ahead and just kind of draw this dotted line, right? That means we will have no x values as 3. Okay, then there is a slant at y equals x plus 4. Okay, this is mx plus b formula. So I'll start with my y-intercept. And then from there, it's a 1 over 1 slope. So I will just bring it across this way. I believe this is the only one on the notes that has a slant. So these are our asymptotes. So somewhere around these, we will have a graph. From here, the only thing you can do is plug in values. So I want to make sure that I choose sporadically a little bit of everything. I'm going to end up using -8. Let's go with -4, 0, 2, 4, and 6, just to give you an idea of what it's going to look like. You don't have to graph every point, but just a few. I'm not going to go through all of the math of plugging these in. You will definitely want to utilize your calculator when doing that. I mean, you can look at it this way, or you can use the original. It doesn't matter, whatever's easiest for you. So like if I were plugging in 0, for example, it'd be 0 plus 0 minus 2, 0 minus 3, so it'd be 2/3 because we have a -2 over -3. So I know that some of these I can just do mentally, but some of them you'll want to end up graphing. So when it's 2, and I've already done the math on these, so I'm just going to go ahead and fill in what I've got. But I will recommend using a calculator when you are doing these because it's going to take a little bit of time. So when I plugged these in, these were approximately the things that I got. So at -8, we have almost -5, so I'm just going to stop it kind of right there. In that general area, you're still going to get a good picture of what it's going to look like. -4, we've got a -10 over 7, which is not quite -2. I'm going to put it about right here. And then we have 2, -4. All right, and then once we get, so as you can see, it kind of just curves. I also know that there is, it touches the x at -2. So obviously we have that here because our x, it should cross at -2, 1, 3. So I am going to go ahead and just kind of have it touch. Granted, it should probably go through, but it doesn't have to be exactly perfect. Oh no, that's 2, -4. And look, I already made a mistake. 0, 2/3. Why didn't I even graph this one? That's my bad. 0, 2/3 is going to be about right here. So let me fix the way that I have it graphed because that looks super ugly. And that makes a lot more sense. I don't even know why that didn't even look right when I was graphing it. Okay, so that was just my bad on plugging in points incorrectly on the graph because I'm attempting to look at my phone and graph it at the same time. So from here, you can just kind of shade through the points and then it just continues to go. So that's how it's going to look on down here. Once you get into like these numbers, as you can see, I have 418, which is completely off my graph. So it's going to be somewhere in this region, but we're not going to worry about it because it's not on there. So that's number 2. I promise I won't make the same mistake on number 3. So let's go down and look at it. We have 3x over x plus 2x minus 2. So we didn't cancel anything out, so we have no holes. Our exponent on the top is not greater than the one on bottom, so there is no slant. Now, horizontal asymptote is about exponents. We have our numerator is less than the denominator one. So that means we have a horizontal asymptote at y equals 0. And then a vertical asymptote is also just denominator, so it looks like we will have 2. One at x equals -2 and x equals +2. So we have a horizontal asymptote at 0. So I'm just going to kind of draw it. You're not going to be able to see it very well, but it's going across the x-axis there. And then we have one at x equals 2 and x equals -2. And again, once you've got these, all you have to do is plug in several different x values in order to get a y value. So I'm going to choose -8, -6, -1, 0, 1, 4, 8. You kind of want to choose a couple over here and then a couple in the center and then a couple over on this side. All right, once I did this, I went ahead, I'm gonna go ahead and put again the values that I got for y, because it took quite a bit of time to plug in those x values to get the y's. But I still just want to show you like a little bit of picture. I know you guys know how to plug in x values to get y values, so I'm not going to go through that. So here we ended up with, there we go. Let's focus just a little bit better. 0, 0 on there, and then we have -1, 1, and 1, -1. Okay, so as it goes this way, you'll basically, you could plug in -2. Oh no, that's wrong anyway. There's where my asymptote is. Again, that's what I get for looking at my phone instead of trying to just video my graphing skills. So it's going to kind of just curve upwards. And then once we plug in -6 and -8, we'll get a good idea of what it looks like over here. -8, we got -2/5, which is going to be kind of somewhere in this area here. And then for -6, I got -9/16, which again is closer to -1, but not quite. When I did +4, I got 1. And then I had also done +8 and got 2/5. So again, it kind of just reflects, it reflects, or it rotates about the origin on these side ones here. So as we plugged in +4, we got 1. -4 is also -1. So this one kind of ends up coming this direction. Again, you can graph more points to kind of see that. And this will go this direction here as well. And you could graph +3 if you wanted to, but that's what it's going to end up looking like. Again, you're just plugging in x values to get a corresponding y. You'll plot those points and then just kind of sketch the graph. All right. Last one, I'm just going to kind of go through setting up. I'm not going to go through and solve and graph everything. I'm just going to walk through the asymptotes once again. All right, so we have, let's see, there's nothing we can do to the top, but our bottom is x + 5, x - 5. There is no holes, since there's nothing that we can cancel out. There is no slant because our coordinates are equal, and because the numerator is equal to the denominator, it is coefficient of n over coefficient of d. So our coefficient of the top is 2, and our coefficient of the bottom is 1. So our horizontal asymptote is at y = 2. All right, and then vertical asymptote looks like there's 2 because we're looking at denominator, and those are at x = -5 and x = +5. So again, I'm just going through the steps of setting that up. So at y = 2, we'll have a horizontal asymptote there. And then we have at x = -5 and x = 5. And then again, you'll want some sporadic points. I think when I did this one, I used -10, -6, -4, -2, -1. I like doing 0. It's just easy to do. I did quite a few when I did this one because there's a few different like slots for graphs. And that is how I ended up doing it. So plug in points to kind of get an idea of what it looks like. And that is how you'll do those. Number 1, obviously, as you can see, is going to be a little bit easier to do. So feel free to do that one and then check it. And then that's what I've got for you guys on graphing.